All right, good morning. We're going to go over the solutions for Chapter 2 review. The test is, actually it's not a test, it's a quiz. On Tuesday it's going to look a lot like this. So if you've gotten behind because it's hard not having that one-on-one or being able to ask questions, I totally get it. You'll have your opportunity for, we'll make it right. I will do my best to get you right. But if you're not there because you haven't done it, then it kind of lands on your lap. And you need to do something about that. I wish I was there to give you a little bit more motivation. Some of you just need that, but I'm going to ask you to do that yourselves right now, and then I'll meet you halfway afterwards when this all comes to a head. All right, number 2. We got a conditional statement. That is an if-then statement, and if-then statements are our friends. If false, given a counterexample. So if the sidewalks are what? Then it rained. Yeah, it might have been, but is there any other thing that would make the first part true and the second part false? You bet. And if the sidewalks are wet, then the sprinklers were on. Or what are some other counterexamples? We could say I dumped a bunch of water from a car wash. There's 1,000,001 things that would make the sidewalks wet besides it raining. So that's what we're after. A counterexample is what you'll be asked for tomorrow. And that is one thing that kind of makes this not so true all the time. Number 3, is the condition true or false? If two angles are supplementary, then their measures add up to 180. That is true. Supplementary and 180. Absolutely. Go to 4. If they're supplementary, then they're, there's our conditional. What is the converse? All right, so you're probably going to be asked for converse, inverse, contrapositive. Have those notes right there so that you can just go there, look it up. Oh, you switch these, you negate these, and so forth. So on a converse, all you do is switch the if-then parts. So we should be looking for if their measures add up to 180. So I would start there. If the measure, I like this one. There's a possibility there and does not. So by multiple guess or multiple choice, then you almost know that it's going to have to be the second one. Let's just make sure. Then the angles are supplementary, and that is correct. So in a converse, you switch the P and Q statements. All right, if two angles are supplementary and measured 180, same statement. Is the converse of that statement true or false? Is it true? So if the measures add up to 180, then the angles are supplementary, and that is true all day long. All right, guess what? We're doing the same one. Supplementary, add up to 180. The inverse. So you look in your notes, and that means you negate the first one and you negate the second one. So if I were doing this test, I just look at the first one and look for anything where if two angles are not supplementary. So we have a possibility here. Oh, possibility here. So now we go to then their measures do not add up to 180. So we need to negate the second step, and there's the do not. So we're going to go with this one. Let's see why this is wrong. This couldn't have been it at all. No, that's not the right one. So the only one it could have been from the very beginning is that. Come on, Sayers. All right, 7. Okay, what is the contrapositive? So the contrapositive is my favorite. That's where you switch them and negate both of them. So you're looking for an if, the opposite of this to start. So that's how I would do this, just kind of streamline a little bit. So if the measures do not add up to, no, this is close, but it's not there. Oh, there we go. Do not add up to 180. Then the angles are not supplementary. Yes, this is our baby right there. All right, when can you write a biconditional? When the conditional is true and the other statements can be false. No, it's got to go both ways. The conditional and its converse are true. So it doesn't matter which statement goes first. So that's a biconditional. Bicycle, right? 2 wheels, 2 ways of going through here. Statement, if two angles are supplementary, then the measures add up to 180. If nothing else, you better remember that supplementary angles add up to 180. All right, if you can write a biconditional, what is it or not? Well, we can. We just talked about the converse being true. If you're lost on a converse, then you're also lost on a biconditional. I mean, it's a bummer. So have those notes nice and ordered and you'll be good. So we can. The two statements are going to be that and that. So remember, in a biconditional, we drop the if then, and we write the two statements, either one first, and then we put an if and only if. So right now, multiple choice, you're only looking for if and only if. So I'm pretty sure that's got to be the answer, but let's just check it out. Yep, there's first statement, there's a second statement, if and only if. Boom. Why even, when you're so good at this, like you are, why even look at the other ones? Because you just know the answer. Life is good. Tomorrow, will they be multiple choice? I don't think so. I think you have to write these yourself. So this is why I'm doing this for you. Maybe this will be a good reference. All right, if two angles are vertical angles, then they are congruent. And that is something we learned yesterday, this morning. Yeah, that's a good one. We got to know that. Remember, two intersecting lines. We know this and this are equal, and we know this and this are equal. Both pairs of vertical angles. Write the converse of the conditional statement. All right, so that would be if they are congruent. Are congruent, then they are vertical. Okay, I will tell you that that is a false statement. Didn't ask me for, but maybe tomorrow I ask you to think about true or false. We know this is a true statement, but the converse is false. We don't know that since they're the same that they have to be vertical angles. They could just be two random angles that just happen to be the same measure, not be connected by intersecting lines. All right. In fact, I'm not going to do the inverse contrapositive. I'm hoping that's skills that you can look up in your notes and just, yeah. I'll just write it real quick. Sorry. Inverse. So inverse is negate both. So if angles are not congruent, then they are not vertical. Did I do that right? No. Darn it. I didn't. Oh well, just show you that when you go too fast, sometimes not the best outcome. Let's try it again. We're going to the very beginning conditional statement. So if vertical angles, then they're congruent. So the inverse is they are not vertical angles, then if they are not vertical angles, then they are not congruent. Woo, that's messy. I am sorry. Write the contrapositive of the conditional. So that's when you flip them and switch them. So it's basically, if you look at the inverse, it's switch those. So if they are not congruent, oh, this is hard to write, then they are not vertical angles. That is true. All right. Identify the property that justifies the statement. KL equals PR, so the distance is equal, so then I can kind of switch them. So I will tell you that is going to be symmetric. Hey, you're going to see a question on these three. Just have what they are right next to it in your notes. This is A equals A. This is A equals B, then B equals A. And this one is A equals B, and B equals C, then A equals C. Okay. How can you say DE equals DE? That is the reflexive property. Just think about a mirror. If you're looking in the mirror, that's U. So U equal U. That's reflexive. All right, two-column proof. You know that these are going to be on there. This is something that this is how I'm going to grade it. If you have, first of all, this and this, statements, reasons. All right, the first step of all proofs are restate the given. AB equals 9x plus 7 and BC equals negative 3x plus 20. I wrote them both in the same line. That's fine. We want to show that AC is equal to 39. Well, we have a very cool thing called the segment addition postulate. I need to see AB plus BC equals AC and tell the world you can justify that with the segment addition postulate. All right, 3. Hey, we can do a little substitution. We know what AB is. We know what BC is. So we go AB 9x plus 7. I'm substituting in the right spot, so you got to be careful. Negative 3x plus 20 equals AC. Okay, and now we have to prove, I'm sorry, AC is equal to 39. I'll just throw that up there, and I'll put in a 39 here. That was confusing for me because that's all given. All right, so that is substitution. Sweet. Now we just do some algebra. We get 6x plus 27 equals 39, and that is combine like terms or simplify. I'm going to go 6x equals 12. And how did I get from here to here? I did subtraction. Remember, we want to get paid a lot more, POE. And finally, x equal to 2. Why in the world can I justify that step? Because that's called division. POE. I'd be happy to see what word you come up with on the test. I choose BAM. All right, same proof, but now we're doing angles. So I'd like to see this. I'd like to see the first one given. I'm not going to rewrite that. The second thing, I would say the measure of angle EDJ plus the measure of angle JDC. JDC equals the measure of angle EDC, the big one. Small plus small equals big. And that is called the angle addition postulate. Okay, we substitute in. We know EDJ is 39. CDJ is 100. And that equals the measure of angle EDC. So we call that substitution. Do you understand that we're doing the same type over and over again? So we're not like saying you have to come up with it, you just have to believe in it. And then we will eventually have you kind of get creative, because that's the whole art. It's like you got to create your own picture. Finally, 139 equals the measure of angle EDC. And that is our good friend addition. P-O-E. Bam! All right. The word bisects means it cuts exactly in half. Exactly in half. So we use the definition of a bisector. That's going to be the key on this one. Here we go. So number 1, of course, is restate the given. I won't do that because it's right there. 2. So we want to prove that AOB is 36. We want to prove that that's equal to 36. What we know is this is 72, and we know that, so we can use the angle addition postulate. Measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Angle addition. Oh, that's getting too lazy. Angle addition postulate. That's okay. 3. We're going to plug in what we know. AOB we don't know. BOC we don't know. AOC we know is 72. All right, now the key here is that these two are going to be equal. Why? Because we have a bisector, so we need to say that they're equal. The measure of angle AOB is equal to the measure of angle BOC. And this is where people are like, well, you said bisector, I know that it's half, but we just used this idea, definition of a bisector. Why does that help us? Because now we can kind of substitute that in. Check this out. Measure of angle AOB plus measure of angle AOB is equal to 72. And that's substitution. Now we just do some algebra. Two of these, two measures of angle AOB is equal to 72. That's called addition. You guys sure aren't used to when you add two things that don't, like an x and an x. That's 2x, that's easy. But you know, this and this are the same thing. So when we add them, we get two of them. Now I'm going to divide both sides by 2. So I get the measure of angle AOB is equal to 36. And I could say division. But Mr. Sayers, I did it a different way. Awesome. That was probably as long-winded way as you could do it. And that's what we do as teachers sometimes. If you have if you kind of not skipped a step, but kind of, didn't write one of these out, it's probably just fine. So don't freak out. I'm not going to do this one for the video. I'll just do it and put it in the notes. All right, vertical angles. We just learned this. That means this is equal to this, and more importantly, this is equal to this. All right, so we're going to use things that have something. So we're going to use 3x plus 1 equal 148. This does not ask you to do a proof, but if I did, then I would justify it with the vertical angles theorem right there. That's how I can say this is equal to this. Then using subtraction, and then division. So it looks like that one. You guys are awesome. I appreciate you. I think this would be an excellent thing to be good at when you walk into the test tomorrow. Thanks.